you. Oh boy, I would have had to go back and redid the whole thing. Thank you. Oh, all right. So for those of you that are watching this recording, we just went through absolute max and mins, and it's just you can find an absolute or a maximum and minimum value can occur at endpoints. You always have to check endpoints when you're dealing with max and min values. So here in this problem, we would consider this a local max because it is a maximum. It's the highest point in its area. But if we're talking about the interval from A to B, it is not considered the absolute maximum because there's a point that is higher over here. So this would be considered the absolute max. This is a maximum, but we usually just call it a local maximum. Then we have an absolute minimum right here because it is the lowest point on this graph, but this is also a minimum value, so we call this a local min. And this one is a local min here also because it's the lowest point around the area, but it's not the lowest on the whole interval, so we don't call it an absolute minimum. So usually we'll talk about absolute and local max and mins. Some books talk about global max and mins. As I said, the terminology doesn't make much of a difference. But what you really have to understand is that if you're looking for absolute max and mins, you do have to look at the endpoints. So local extreme values, a local one means that it's a maximum in an interval, but it's not the absolute max. And a local minimum, same thing. It is a minimum value, but it's not the absolute minimum. Okay, so it's the lowest point in its area. Now, to find extreme values, okay? So here is let me give you just a real simple equation. Y is equal to x squared plus 3. So we know that this graph looks like this. 1, 2, 3. It's a parabola that goes up. Okay? What is the absolute minimum value for this function? Okay, what is the absolute minimum value for this function? We can see it off the graph. 0. Okay, so this is 0, 3, isn't it? This point. Now, how do we use calculus to come up with absolute max and absolute minimums? Well, when a derivative, what does a derivative give us? Gives us the slope at any given point, right? So if the slope is 0, isn't that a horizontal line? So basically what we're doing is we're taking a derivative and we're trying to set it equal to 0 and solve because that'll give us the value of a horizontal line that is tangent to the graph, which would mean it's a max or min. So if I took the derivative of this, this is going to be 2x. I'm going to set it equal to 0. And if I solve this, x equals 0. Well, we already knew x was equal to 0 because we could see it on the graph. And if I put 0 back in here, I end up with 0, 3. So that is my minimum value of this function, because if you take the derivative, set it equal to 0, that will give you either a maximum or minimum value. Why? Because that's where the tangent line would be horizontal. Okay, so this is probably one of the big concepts in calculus, is if you set the derivative equal to 0 and solve, you're going to end up with a max or a minimum value of the function. So this is where this is Khan Academy. They use local maxes and then global and local. So in this one it says over the region shown between x equals 1 and x equals 3. So between 1 and 3, the point B is, and I would say that is a global minimum. It is I wouldn't say global, I would say the absolute minimum, because it is the lowest point on there. But Khan Academy uses different terminology than most textbooks do. In this problem, it's the region shown. There are local minimums at the points, well, point C. There's a local minimum at point C. That is it. A and B would be local maximum. Well, B would be in a global. In this one, over the regions 1 to 3, I love this question because it says over the region between x equals 1 and 3, the point C is, well, it's not even in that interval, is it? It's like, guess not. So, well, I guess it doesn't have to be in the interval, but point C would be considered a local minimum. All right, so now this is a type of problem that I would give you. It says, which of the following values is the absolute maximum of the function 4x minus x squared plus 6 on the interval from 0 to 4? Okay, so what I'm going to do in this problem, first thing I'm going to do is I'm going to rewrite it so it's in standard form. So f of x is equal to negative x squared plus 4x plus 6. And then I'm going to take the derivative. And once I get the derivative, I'm going to set it equal to 0. So that's going to be negative 2x plus 4. I'm going to set this equal to 0. So if I subtract off 4 there, negative 2x equals negative 4, x equals 2. So now it wants to know what the maximum, the absolute maximum value is on the interval between 0 and 4. So what I need to check out now is I need to check out f of 0, because that's an endpoint. I need to check out f of 4, that's an endpoint. And I need to check out f of 2, because this is set equal to 0, so I know it's either a max or min. So let's check this out. So if I put 0 back into my original function, that gives me 6. So 0, 6 is a point on my graph. And if I put 4 in here, 4 squared is 16, so that's negative 16 plus 16 plus 6. So that's 6. And if I put 2 in there, so 2 squared is 4, so that's negative 4 plus 8 plus 6. So what is that, 14? That's 10. So if I was trying to find the absolute maximum for this function, it is going to occur at x equals 2. And when they ask you for an absolute max or min, they're looking for, usually they're looking for the x value, not the y value. They want to know what the x value is for that. All right. Any questions up through now? Okay, how to find absolute maximum. It's just basically taking derivative, setting it equal to 0. Oops. All right. The mean value theorem. The mean value theorem, if f is continuous on the closed interval a to b and differentiable on the open interval a to b, then there exists a number c in ab such that f prime of c equals f of b minus f of a over b minus a. Oh, okay. What the heck does that mean? All right. Does anybody recognize this formula right here? Oops, my marker's not on. What is this formula? Definition of a limit? Oh, that's pretty close. If it would have said the limit as add, that would do it. But nope, I'm not gonna go with that. What if I wrote it this way? That is a slope formula. Yeah. This is a slope formula because this really is y, isn't it? When you plug b into f, this would be y2, this would be y1, this would be x2, x1. This is a slope formula. All right. So what they're doing, what they're saying for the mean value theorem is they're saying that there is some value of c that it equals, the derivative equals the slope. So let me give you a visual example. So here is, I'm just going to do y is equal to x squared on the interval 0 to 4, okay? So it's going to look something like this, isn't it? It's going to go up like this. Oops. and go up like that. So here it's 0. This is 0. This is 0, 0. And at 4, this would be 16. Okay? So now, what they're really saying is, they're saying that if you found the slope between the two endpoints, okay? So I can do that. That's not a problem. I can find the slope of this line here. Okay, that would be 16 minus 0 over 4 minus 0, or 4. So the slope of this blue line, if I connected these 2 points, if I found the slope of this line here, the slope equals 4. Now what the mean value theorem says, it says that on the interval between 0 and 4, so this is my interval, 0 to 4, there is a point someplace in here between 0 and 4. That's why I can always tell if a student doesn't understand this, because the C value has to be between 0 and 4. It can't be 0, it can't be 4, it has to be between there. So the C value has it. So if a kid gives me an answer like C equals 5, it's like, they don't understand the concept here, because the C value has to be in that interval. And what it is, what it's saying is there's a value of C such that the slope of the tangent line at C is going to equal the slope of the secant line, because this is really a secant line, isn't it? If you draw the line between the two endpoints of any graph, that's called the secant. So the slope of the secant is equal to the slope of the tangent line at some point. Oh, okay. Well, I know what the slope of the secant line is, right? It's 4. I know what the derivative of this function is. Derivative of x squared is just 2x. So all I do is I set 2x equal to the slope of the secant line, and I solve, so x equals 2. So that means C equals 2. At 2, I will, if I drew a line, a tangent line at x equals 2, it will have the exact same slope of the secant line. And doesn't that make sense? Because if I put 2 into my derivative, guess what? I get 4, and that's the slope that I wanted. So visually, this is what they're doing. They're just saying that there has to be a point C, someplace in the interval, that the tangent line and the secant line are both parallel. That means they have the same slope. Okay, that is what the mean value theorem says. Oh, and that was mean value theorem again. All right, and here's a diagram between, if you did it between 0 and 2. So here's a problem. It says find the value of C that satisfies the mean value theorem, f of x equals 3x squared plus 5x minus 2 on the interval between -1 and 1. Okay, so I'm going to let you guys try that one and see what you get. Okay, so give it a shot, see what your C value is. Okay, any answers yet? What does C equal? You're stuck? Okay. You got 0? All right. Now, 0 is a reasonable answer because it is between 0 and 1, right? So the first thing I do is you don't have to draw the function out. That is not important. I usually do because I'm a visual learner and that's the way I see things. I believe the graph looks something like this, if I'm not mistaken. I know it's a parabola. I think it comes down here and then it comes back up, but that's okay. If you don't have a good graph for it, it doesn't make any difference. What I do need is I need f of -1. I need to know what that is equal to. I need to know what f of 1 is equal to. So if I put -1 in here, -1 squared is 1, so that's 3 plus -5 minus 2, that's -7, so is that 4? So at -1, I'm at 4. Okay, -1 comma 4. And then 1. So if I plug 1 in here, 1 squared is 1, 3 times, so that's 3 plus 5 minus 2, so that's 8, that's 6, if I'm not mistaken. So 1, 6, I'm up here. It's kind of a weird one, but -4 for -1. Did I mess this up? So -1 squared is 1. So 3 times, so that's 3. Oh, that's -5. Oh, I did it up here. So that's -5. -7 and 3. Oh, that's -4. I don't know. So -1. So -1, -4. Okay. So -1, -4. Sorry about that. All right. Now, you'll never get these right if you don't do the math correctly. Okay. So now what am I going to do? I'm going to draw a secant line in because I need to know what the slope of the secant line is. That's the first step when you're doing these types of problems. You need to know what the slope of the secant line is. And what is the secant line? It's where the two endpoints meet. Okay. So I've got -1, -4, and I have 1 comma 6. So that's going to be 6 minus -4 over 1 minus -1. So that's going to be 10 over 2, or a slope of 5. Okay. Am I correct on that one? Is the slope of the secant line 5? Okay. So now what I need to do is I need to find the value C such that when I draw the tangent line in at C, the slope equals the slope of the secant line. Well, how do you do that? Well, you've got to take the derivative first. So I'm going to take the derivative of my function. So that's going to be 6x plus 5. And I'm going to set it equal to the slope of the secant line. So that equals 5. If I subtract 5 off there, I end up with 6x equals 0. X equals 0. That means, and obviously this is not a good graph, but C has to be 0. So when C is equal to 0, the slope of the secant line and the slope of the tangent line are exactly the same. All right. Does that make sense, Isabel? I think Esther got it correct. Okay. One more for you to try, and then we're going to do an AP type question off of this. So this one here says x to the third minus 6x squared plus 12x, and it wants you to find C to be a number that satisfies the mean value theorem on the interval from 0 to 3. Okay, so what is C? Well, in this problem, I could cross off two answers. I could cross off 0 and 3 because your C value cannot be end of the interval. Okay, so I know it has to be either 1 or 2. If I had to take, well, I'm not going to guess because I don't know what it is. All right, so why don't you guys give that one a shot, and then we'll go over that. C equals 1. Okay, that was pretty quick. All right, I have to. I'm just plugging this in my calculator and seeing if I can find a halfway decent graph of this thing. Oops, I wanted to zoom in on that, not zoom out. No, that's not working too well. All right, so I think the graph looks something like this. I think it looks something like this. All right, so I need to know what the value is at 0. So that's pretty easy because you put 0 in here, that's all zeros, so that's going to be 0. So 0, 0 is a point. And then if I put 3 in here, is that 27 minus, so it's, is that 54 plus 36? So that's 27, negative 27. Is that 9? Is that right? All right. Phew, I got something right today. All right, so I've got 0, 0, and 3, 9. For next thing I'm going to do is I'm going to draw the secant line. Secant line is right here. I need to know what the slope of that is. So 9 minus 0 over 3 minus 0, that slope is 3. So now I have the slope of the secant line. So now I need to find where the derivative is equal to 3 also, because then I would have two equations that have the same slope. So I'm going to take the derivative here. So that's 3x squared minus 12x plus 12 is equal to 3. All right, I'm going to bring the 3 over to this side. So 3x squared minus 12x plus 9 is equal to 0. I'm going to factor out a 3 to make it easier to solve here. So that's going to end up being what, negative, so it factors down to x minus 3x minus 1. So this would give me a solution of 3, which I know can't be. So 1 is the correct answer. Yep, very good. All right, so does that make sense? How we find the secant line? All right, now I'm going to give you a problem off today's assessment, or one of them. This is a good problem. This one was off an AP exam, okay? But it really takes you step by step through the mean value theorem, okay? It says, let f be the function given by y of f of x equals negative 2x squared plus 8. Okay, so it's graphed up there for you, as shown above. The graph of f crosses the y-axis at 0, 8. Okay, so crosses the y-axis at 0, 8. So way up here, let me turn my marker on here. So way up here is 0, 8. And the x-axis at 0.20. So this point is 2, 0. So they gave me all that information. Awesome, thank you. It says write an equation for the line passing through the points P and Q. Okay, so they want me to write an equation for this line. Well, what do we need in order to write an equation of a line? We need point and a slope, right? Well, I've got 2 points. I could take either one. I'm going to go with 0, 8. And then the slope, well, 8 minus 0 over 0 minus 2. So that looks like negative 4. So my equation is just going to be y is equal to negative 4x plus 8. That is an equation that goes through that point. But why did they want me to do that? Well, because now I've got the slope. Then it says write an equation for the tangent to the graph of f at point Q. Okay, I forgot which one point. So Q is this one right here. So they want me to write an equation of a tangent line for that one. Well, in order to write an equation of a tangent line, and a point, well, I know the point is 2, 0 because they gave that to me. And I also need the slope. Well, to find the slope, I'm going to take the derivative of this. So that's going to be negative 4x. And then I'm going to plug 2 in there. So that gives me negative 8, doesn't it? So now I have y is equal to negative 8x. Oops, I want to do it in point slope form. So I've got y minus 0 is equal to negative 8x minus 2. And I would just leave it like that. Oh, it did tell me to put it in slope intercept form, so I guess I will change it. So y is equal to negative 8x plus 16. Is that right? And then the last question, it says find the x-coordinate of the point on the graph of f between P and Q at which the line tangent to the graph of f is parallel to P and Q. So they basically ask you to find the C value for this problem. So I already know my derivative is negative 4x. I know my slope up there was negative 4, wasn't it? The slope of the secant line. So I'm just going to set those equal. So x equals 1. And that would be my answer. So this was a problem off a previous AP exam. Not too bad, but you did have to know a lot of different things. I mean, the AP exam tests you on lots and lots of different things. All right. Now, the last thing for today is finding where a function is increasing and decreasing. Okay. So I'm going to give you, I don't know if I have a clean sheet of paper here. Darn it. So I'm just going to cross this off here. Oh no, I won't cross this off. This is another problem off your assessment for tonight. Okay, for this week. I shouldn't say tonight because you don't have to do it tonight. This is another problem off the assessment for this week. It says, let f of x equals the square root of x plus 9, and let c be the number that satisfies the mean value theorem for f on the interval between 0 and 16. What is c? Okay, so I'm going to let you guys work on this one, see what you get. All right, any answers yet? C equals 7, and I am stuck. Now, C equals 7 is in the interval, so I would probably say it's right because it's in between 0 and 16. Now, if I was going to do this problem, x plus 9, the square root of x plus 9, I think that starts way back here at negative 9, and it looks something like this. So I'm looking for between 0 and 16. So if I put 0 in here, and so this is 0 here, and let's say that this is 16 here. If I put 0 in here, 0 plus 9 is 9. The square root of 9 is 3. So this point here is 0, comma 3. And if I put 16 in here, 16 plus 9 is 25. The square root of 25 is 5. So this point right here is 16, comma 5. So the next thing I'm going to do, I'm going to draw in the secant line. Okay. I'm going to find the slope of that secant line. So 5 minus 3 over 16 minus 0. So 5 minus 3 is 2 over 16. So that is 1/8. Okay. Now, I need the derivative of this. Well, the derivative of x plus 9, I would write it this way. So I'm going to bring the 1/2 down, leave the middle alone, times the derivative of the middle, which is just 1, so that doesn't make any difference. So my derivative is 1 over 2 the square root of x plus 9. Okay, so I need to set that equal to 1/8. Uh-oh. Oh my goodness, how am I going to solve this? Well, it's a proportion, isn't it? I'm going to cross multiply. So I've got 2, the square root of x plus 9 is equal to 8. I know when I'm solving a radical, I have to isolate it. So I'm going to divide through by 2. So I end up with the square root of x plus 9 is equal to 4. Now, to get rid of the radical, I'm going to square both sides. So I end up with x plus 9 is equal to 16. I'm going to subtract 9 from both sides and end up with x equals 7. That is an amazing problem. I mean, you have to know so many things on that. And there's not, and this is where, a lot of students say, well, Mr. Schenkel, I can't do calculus. It's really not a lot of, what is the only calculus that was in this problem? Right here, being able to take this derivative. That was the only calculus in this whole problem. The rest of it, finding the slope between 2 points. Here, solving a radical equation. So the only thing that was calculus is right here. That was it. The rest of it was, algebra 2 kind of material. But that was a good problem. I like it. All right, now, I got away from what I wanted to really do because I was just trying to find a sheet of paper where I can. So I'm going to cross this out now. All right. So if I gave you this equation, y is equal to x squared, and this is the graph of it. Okay. Where is this function increasing? Where is this function decreasing? Where is the minimum value? Okay. So where is this function increasing? What is the interval where that function is increasing? When y is positive. So that. So decreasing would be that. And the minimum value would be 0, 0. Okay. Intervals are always x values, not y values. So if I'm saying where is it increasing, we look at the x-axis between 0 and infinity. This is negative infinity here. So it's decreasing from 0 to negative, or from negative infinity to 0. It's increasing from 0 to infinity. All right, now, calculus-wise, I could take the derivative of this and find out, that's not the derivative. Derivative is this, and find out where it is greater than 0. That is where it would be increasing. Well, if I divide through by 2 here, x is greater than 0. So that's where it's increasing. If I want to know where it's decreasing, I would just say, okay, the derivative is less than 0 because that means it's decreasing. So x is less than 0. Okay. Where is the minimum value? Well, if I set 2x equal to 0, x equals 0. So we can take a derivative and find out where it's increasing and decreasing. Or, this is what I really want to get across today. Or we could take or if you're given the derivative graph. So if I gave you this and I said that this is y is equal to x squared, the derivative of that is 2x, right? So what does the derivative graph look like? Doesn't the derivative graph look like this? Okay. So looking at the derivative graph, can you tell me where the original function was increasing? Anytime the derivative graph is above the x-axis, anytime the derivative graph is above the x-axis, the original function was increasing. Whenever it's below the x-axis, the original graph was decreasing. Where it crosses the x-axis, it is either a max or min. How do I know if it's a max or min? Well, this part is decreasing, then it increases. So if your function is decreasing, then increases, this has to be a minimum value. So let me give you a derivative graph. I'm just going to make one up. Okay. So I'm going to tell you that this is a derivative graph. I'm going to put some numbers in here. Yeah, this is 0, this is 1 and 2. All right, there's my derivative graph. What intervals is the original function? We don't know anything about the original function, right? All I know is that's the graph right here. Where is the original function increasing? What intervals? X is less than 2? Increasing? I disagree with you that. I agree with that since it's above the x-axis right here. Now it's above the x-axis. Between -2 and 0, the original graph is increasing. Yeah, but that wouldn't have been correct either because it decreases again. And then, oh, I'm sorry, above 2. Yep. So then I would also say 2 to infinity. So both of these intervals, the original graph is increasing. Okay. Where is it decreasing? Well, anytime it's below the x-axis. So -infinity to -2, decreasing. Between 0 and 2, decreasing. Where is the max? Are there any max values? And if they are, where do they occur? X equals 1? This is -1. Nope. A maximum or minimum value must occur, must occur where the derivative graph crosses the x-axis. So I know there has to be a maximum or minimum value right here. I know there has to be one right here. I know there has to be one right here. Is this, let me change colors. That's not a very good color. You can't see it. Is this value right here a max or min? And how do I tell? Well, guess what? What is this function doing? What is this derivative? This is decreasing, then it's increasing. So if a function decreases and then increases, what is that value? Is that a minimum or a maximum value? That is a minimum value. So what is this value? I know it has to be a max or min. Okay, it has to be a max or min. So now, since the graph is above the x-axis, it's increasing, then it's decreasing. Well, if something is increasing and then it decreases, that has to be a maximum value. This value here is max, right there. And this one, again, would be a minimum value. So a derivative graph gives us so much information. It tells us where the original, even though we don't know anything about the original function, nothing at all. If I know the derivative graph, I know where the original graph is increasing, decreasing, and where its max and mins are, just by looking at the derivative graph. There are so many problems on the AP exam that deal with derivative graphs. It's not even funny. And they're so easy to do. I mean, as long as you understand that everything below the x-axis of a derivative graph, the function is decreasing. Everything above the x-axis, it's increasing. Then it's like, okay, now I know where it's increasing, decreasing, and all that. So there's a problem on the assessment tonight, or this week. It's not what I wanted. It's not what I wanted. Oh, did I not put that problem on there? Ooh, I didn't put it on there. Darn it. Okay. So there's a couple different types of problems on the assessment for increasing and decreasing. If they give you just the original function, okay, then all you have to do is just graph it out. And here's the graph. And you can tell where it's increasing and decreasing just by looking at it. I know it's decreasing from negative infinity to, I don't know what that point is. It looks like, darn, I should have enlarged this, but you can see, I mean, it's decreasing here to this point, and then it increases, then it decreases, then it increases. So this is the original graph, y is equal to. Now, if I give you a derivative function, so let's say I gave you something like this for your assessment tonight. And I said f prime of x is equal to, I don't know, x plus 1 over x plus 2. Okay, that's the derivative. Okay, well, if I graph this thing out, I think it looks something like this. I'm not 100% sure, but I think it looks something like that. So you would know that this function is always increasing from 0 to infinity and always decreasing from 0 to negative infinity, because wherever it's above the x-axis, wherever it's below the x-axis, that tells us what's happening with that function, or what the original function. Does that make sense? So that derivative graph is really, really, really important. And there's a problem on tonight's assessment that it gives you some crazy derivative and it asks you where is it increasing and decreasing. All you're going to do is you're just going to plug it into a calculator and you're just going to look at the graph, and wherever it's below the x-axis, that's where the function is decreasing. Wherever it's above the x-axis, it's increasing. That's it. Don't make those problems. I think there's 2 of them like that. Don't make them hard. They're really easy. Just throw them in a calculator, find out where it's above and below the x-axis. It makes it super simple. All right, that is all I have for you today. Any questions? All right, you guys have a great week. We'll see you back next week, same time, same place.